Hello everyone, Ken here, back with part 6 of the Data Science Project from Scratch series. In this video, I'm going to take our model that we made in part 5, where we predicted Glassdoor salaries, and I'm going to turn it into an API endpoint using Flask. This is known as productionization, and with an API endpoint, we can have a website, reach out to it and get back a response. In this case, for example, our website would send information related to a job, and our API endpoint would return an expected salary. Now, I think that this is really cool, and if you remember back to part 2, where we actually scrape this data, part 3, where we clean this data, and part 4, where we explain this data, we've really come a long way in this series. If you enjoyed this video, please hit that like button, and if you want to see more similar to it and see the last maybe bonus section of the series, please subscribe and turn on notifications to be alerted when I post that. Okay, so let's actually get started on building this Flask API endpoint now. So as usual, the first thing that we do is we pull down our Git repo. So we change into our directory and we git pull. That pulls down the code. It is already up to date. Now we're going to create a branch. So git check out -b, and we're just going to call this Flask API. And now we are working off of that branch. So I left the code up from last time where we'd actually built our model. That took a long time to train. So we want to make sure that that is already done. Otherwise this video would take forever. But let's just look at our best estimator real quick. So a random forest uses, you guessed it, randomness, and I did not set a random seed. So this time when I ran it, I got a different number of estimators. It's still using the mean absolute error criteria, but this is something that we want to pay attention to in the future. So next time I'm going to add in a random seed so that we get the same optimal output every time. So the next thing that we do is let's go on a handy Google search and let's just try and see what's out there for productionizing a model using Flask. So it looks like I've actually viewed this one before. And remember, we're going to document this, so shout out to Chris in our readme of our project. So this is a pretty good diagram, actually. So our model is going to sit here. A kind of a translation code is going to sit just in front of it, and it's going to sit within this Flask framework. So Flask, for the use case of this video, it's a very basic web framework, and it's just going to create a very simple web server on our local computer. We're not going to do this Heroku part, that's putting that web server online to make it accessible. We're just going to do this on our computer, but going beyond that and putting it up is not overwhelmingly difficult. So again, this client would be like a website that we built. It would send a request with the data that it's putting in. So this would be like what type of job it is, the age of the company, all those things that we found in the previous sections. Our model would read it and it would just send back a response. So the Flask is a wrapper. Let's see here. So I think that there's a couple things we should probably do. So we've already built the model. We've already done quite a bit of this. We have to pickle the model. So when we pickle the model, we abstract it. So we make it usable by other programs without having to retrain it. So it's just a model object that has been already trained, which is exactly what we want for this use case. So we're going to import pickle. Instead of this model here, we are going to use gs.est estimator. And we can just import that. So if we do, let's just test it really quickly. Let's go down. I have to remember how to actually, so he loads in models. So pickle, okay, let's just copy this code real quick to test that our model actually works. So we're just going to load back in that model that we, oops, that didn't work. We're going to load back in that model that we just saved. So let's show you where that saved model is. So we have our model file P right there. So we're just going to load this back in. And so file name is, I'm just going to remove that. Come on, baby. So we should be able to use this model that we built before, dot predict. And then let's take x test dot lock. We're gonna want, so this is gonna take just like the first row of x test, I think. Oh, we need ilock, sorry guys. Ilock. There, so we just get this row coming in, and I think we have to make it into the correct format that that this data frame would want. So let's make it into values and see if that works. Okay, so it just says I need to adjust that data, so let's just do shape 1, -1. Nope. Okay, so our first value that does work. It returns, $53,000, which I think would be probably kind of low, but I haven't actually looked. This might be a part-time position or something like that. But so we know that pickled object does work. Let's save that real quickly, and then let's move on to some next steps here. So we want to go ahead. I think we're gonna have to set up some environments and stuff. So yes, we're gonna have to go to change into our folder here, and oh man, I've been doing that so much lately. Okay. So we are going to make a new file, Flask API, and then we are going to change into that. And then let's see here, let's just make this a little smaller, we don't need all that. So we also want to make a virtual environment. So whenever we do a new project, I probably should have done this at the start of this one, we want to make a new environment so that if someone else is using the project, they can go in and know all of the packages that need to be used. So what you can do is you can freeze the requirements, and then that person can just install all of the packages that are relevant to that specific project. In data science, we don't use that as much because we use a lot of like heavy lifting projects, but in web development and some of these other things, that's what makes code usable by other people, because you freeze all of the actual like packages, the versions and stuff that you need. But so in this one, let's just make a quick conda environment. So we do conda activate. Let's make this bigger again. -n, and we're going to call this Flask env, and then Python equals 3.7. So this is going to make a new, oh, not kinda, sorry, it's kinda create. We'll get to the activate portion. Looks like I already own that, but we'll rewrite this. So we make this new environment. This just creates like a new instance of Python on our computer. An environment, this would be like making a new virtual machine with nothing on it. So now we actually want to go into that. So we do conda activate Flask env. Oops. And so now you can see that we're actually using that environment. Let's install stuff. So we're going to use conda install Flask. So it'll ask us a couple questions. Yes. This might take just a little bit here. The next thing we want to do is, oh my goodness. Okay. We're not going to use Gunicorn. That doesn't work on Windows, so I will not be able to do that. Instead, we're going to do this locally. Let's make sure we have some of the other packages that we'd use, though. So uninstall pandas. And then we'll probably want sklearn as well. Again, sorry about the sirens. That's kind of part of living in the big city. Install scint. And I think that this should be all we need for our environment here. So we're going to do a little bit more from the actual terminal than you've seen me do in the past. That's kind of where you spin up the web server. So now that we actually have these, we're just going to do pip freeze requirements.txt. So this is going to make that requirements folder, and we should be able to see that in the file explorer. Give me a second here. Yeah, so we created this, and then we see requirements.txt in there. That's the only file, but we're going to make some more. So to make files, we do touch. So touch app.py, touch pro c file, touch wsgi.py, and then Pickle models. Cool. So now that we have all those put together, let's go through and see what we need to do here. So in our app.py, we're going to copy this, and then we're going to open this, and we're going to paste that in there. So obviously this doesn't look too pretty, spacing's kind of funky. Let's fix that. Cool. So we have our app.py app. Now let's go back in this. So this is what we use to actually run the app. I'll show you what that looks like in a second. So now we should be able to actually get this up and running. So let's see what a actual request looks like. So since we're in this file, we can do lsgi.py, and this is going to initiate our, oops, sorry, we're going to have to do Python. And this starts the web server going on our local host. And then we can make a curl request. So curl is what you usually use at the most basic level to access APIs. Again, this is going to be hosted locally, and we have to change this to our own address up here. We can also make requests from the Python command line, but this is just a quick way to test this. So we're doing 127.0.0.1:5000. And so we get this response, yeah, which is what is currently coded in our get response here. So it just dumps yeah onto the screen. But that means it returned, and we actually made this connection between this API framework that we built and some other server that's reaching in and connecting with us. So I think that's a pretty good first step. There's a reasonable amount of success there. So we pickled our model already, and we have it located here, and then we just want to move that into this models folder that we've created in that. So let's move this into Flask API, and then model P into models. Okay, so what do we do next? We want to include this load models code here, and that's just going to go right above predict. And so, I mean, I don't want to get too much into the Flask infrastructure, but basically you can make routes which would just be like pages on a website, and whenever you you send a response with this URL, you can respond with like sending back a HTML page. And that's how you actually just build a website with this, is that you have you're sending a lot of requests, and what you're responding with is actually just a web page, and it's being shown to people. So again, this is like a very simple web framework, but it's very flexible and it's very powerful. Next, we want to make our predict function so it looks like this. It's sort of what we're going to make it look like. So in his example, it looks like he's only using one variable that's going in. In our example, we're using like a lot of variables that are going in. So what we probably want to do is let's go into this, and let's actually just make a new kind of dummy file, and let's save all of the data from xtest from like this right here. Let's make a list of that. So we're just going to copy this, oops, and we're going to put this in untitled. So let's call this data in is equal to that, and we're going to call this file. Oops, not the right one. We want file, save as, and we're gonna save it in here, data input. And then in our app.py, we're gonna import data input from data input. Import data in, and this is just going to save that variable locally. We just need to save that. It does not like that. Oh, okay, sorry guys. We have to just change our directory here, and this should work. There we go. So instead of X here, we can just do data in. And I think this should hopefully work. So we're just saving that local variable. This is just, again, for testing. We want to get our actual model to work. So we're going to try and predict. So this is coming in as a list. So let's see, for this, we want to figure out how to get a list of this. Actually, I think I can do that without fooling around with that too much. So we want to get a NumPy array of that, and let's import NumPy, and then we reshape 1, -1. And then so if we predict this, we should get a decent output here. So let's go back and open this up. Let's clear this and then run it again. Yeah. Yes. Ah, the old syntax error. Let's try that guy one more time. All right, we got our server running again. We're going to send it a request, and instead, this time, it should send us back a, nope, we got a little error action. So I have to import Pickle in here. Did I forget to do that from his steps? Ah, yeah, import JSON. That's already in there. and pickle. So let's try that one more time, guys. Still didn't like it. Okay, so we ran into some errors. I realized that this has to be on top of predict. That was a foolish mistake that I made as well. Let's try and experiment with these. Looks like I commented these out. Model. Let's actually just go back and replace all of these. So we're gonna do this under predict. Oops. So we're just gonna replace all these. There we go. And so for X, again, we're gonna be taking data in. So we have to import NumPy, array, data in, and then we want to reshape 1, -1, just like we did in our other workbook. We don't need all these things around that. And we should be able to return a response with this. So let's see if we can actually get that to work. Moment of truth. Oh, great. We get the response that we're looking for. So what we now have to do is actually send in this X array rather than just include it, because we want the user or the other server, or the client, sorry, to be able to send us the information that they want to transform. So again, we have this data in, and we're gonna switch from sending the requests via another terminal to doing it from a Python notebook. So I think that there's like 1 or 2 other things we actually have to do with this code to make that possible. So we have that. We're not going to use that. So we have to change that X code here. So we're going to change it to do this. And then we are going to pass this a list instead. And then we want X in that list to take that same format, right? So it would be NumPy array X dot reshape 1, -1. And so then let's work on, there we go. Now let's work on actually building that requests file. So we're going to use the requests directory, I believe, to get that done. So let's go here. Requests Python. So let's go back to our handy productionize this. He's going to show you what we need in the request. So we need the URL, we need the header, which is content type, and then we also need to send in data, which is input, followed by our list. So again, we can do that using requests. Let's see what that looks like. So we're going to go here, we're going to import requests. And then we're also going to import this data input. No, we're going to import from data input, import data in, And then we are going to, for URL equals so to copy from the terminal in Windows, you can press Control-Shift-C, which I think is very helpful. We want to take the I believe it's params. Okay, request, so we're going to feed in data like that. I think we can send in the header as a parameter. We will see what that looks like. Let's go back to that first page. Params, and in our there we go. Okay, so actually I think we would call this headers, and then I think the content type we'd want to do like that, right? That seems to make a bit more sense to me. Now we want to send in the data. So we're going to take our data and we're going to make it into a dictionary. So we're going to send it via JSON, and JSONs are very similar to dictionaries in our in Python. The structure is actually, I think, identical. So we're going to follow this structure. So it's going to be input colon data in. So that should send that that list over. So now we're going to go back here. We're going to do requests. R equals request.get URL, headers equal headers, data equals data. I think that should work. Well, I think maybe this is, since it's JSON, equals data. So let's log all those and then see if we can, if this works on the first try. My brain will explode. So we started the server up again. Let's try and send a request. And then we have to do r.assign. Okay, so we didn't get anything back from our server. It did get the request though, and we got a 404 error, which I am familiar with, but let's Google it. So something was not found. Let's see. Let's look at our app. So our biggest thing is we just didn't get anything back. So it looks like the request was made. and it just did not have anything with it. Alright, let's go in to this, and we're just going to print X, see what that looks like. So when we send out this request, let's see what happens on this end. So same thing, it looks like we're not getting any data from the request.url. So, oh, that's why. We're not doing, we have to do predict, right? Otherwise, it will not work. And let's see if that is capped or not. It is lowercase predict, so let's try this out. I think that our request was broken because of that. Let's see here. Okay, so let's close this, start it up again. Oh my goodness, yes, it worked. So r.json, and then we get a response. So let's see here. Let's go back to this. So it looks like, obviously we can comment this out. Our request is working. We're able to send from a client to our server that we spun up and get a response here. So let's just run this one more time. We'll show that it doesn't print everything out. Oh, it still prints everything out. I did not save it. There we go. Okay, so we get our response. Wonderful. So again, how this would work is you could So again, how this would work is you could have a website. You know, the website, you put in the parameters, you press send, it sends all of the data to our server here, and it responds with the actual prediction that we're making. So maybe this wouldn't be the most effective infrastructure. Maybe calling, like saving all of the values and calling from a database would make more sense from a time perspective. But this is how you would generally go about productionizing something. We could also put this online, you know, via Heroku or via AWS, and make it accessible to anyone that was willing to use it. So this is generally what's known as a RESTful API. You just send it data. You don't have to know what's going on within the infrastructure, and it will return with a response here. So let's save all this stuff and push it up to GitHub. So let's save this as requests, and then we'll save all of our model building. We have again this Flask app. We have the requirements. So if you wanted to run this on your machine, you could just install the requirements from that folder. And yeah, so we're gonna go back here. We're going to add that, git commit -m, git push. We're gonna have to set it upstream. Git push set stream origin Flask API. All right. So now that we have all of this pushed up there, we can go in. We'll refresh it. We are going to Flask API, create a new pull request, create pull request and then let's go ahead and merge this. So I was planning for this to be the last episode of this series where I'd go in and productionize this. Again, productionizing your code makes it clear to employers that you know that your project, your analysis is going to be used, and it turns it from an idea into a concrete product. What I want to do in the last episode, which probably won't take that long, is I'm going to go through and do the readme for this project and include everything that I think is relevant from each of the stages. I think that that's really to show you how you should be presenting these things for employers to find them interesting and relevant. You know, employers are really only going to take a quick look at this, and maybe if you get to the next round of the interview, they'll dive into some of your code. But you want them to be able to see everything in this repo that would make them convinced that you'd be a good candidate for the position you're applying to. So let's say we'd probably take some pictures from our data exploration page and put them in there. We'd probably want a summary of the whole project and our findings. So I'm going to go through those in part 7, which will kind of be a fun little bonus feature for everyone. As usual, thank you so much for watching. Good luck on your data science journey, and stay tuned until next time.